Well, welcome everybody. This is lesson 7. In this section or this lesson, we're going to be talking about statistics. Now, I know this is a section that some individuals would want an entire class on, others would not want to do any at all. But in some cases, people might believe that statistics at face value is not inherently interesting or in fact just downright boring. However, statistics and understanding at least the basics and understanding how those are calculated are important because statistics can be used to measure and help us understand and make decisions on all sorts of things in our life. In terms of the amount of physical activity that's important for us, diet, nutrition, medicine, pharmaceuticals. So it is important that when you're dealing with health science research, kinesiology research, that you have at least a good understanding. And even if you're not going to actually be crunching a lot of the numbers in your career, if you're reading through literature, having an understanding of some of the basics of statistics will allow you to make some important decisions, informed decisions about what that article or if that research is useful to you in your practice or working with clients, or it might be something that has some limitations. So we're going to be talking about this throughout this lesson. Let's get started. This first part is going to talk about statistics up to inferential statistics, and then we'll have a second part where we'll do inferential statistics. So make sure that you look over both sections to determine the entire gamut of what statistics are, and again, having the basics for them. So some basic terms to review with statistics is you have parameters, which are values obtained from a population or a census, and then you have statistics themselves, which are values obtained from a sample. So both of these will kind of give you an idea of how statistics will be determined. And there's two different types of statistics that we'll be talking about, at least in terms of global terms. Descriptive statistics are used almost in all types of research, and they help to summarize and describe data that have been collected. So think about it as, let's say, the average age of the population, or the average body weight and height, or BMI. So just giving it, just like it says, describe. You're just describing, giving the reader an idea about the population or the sample that you used. And that'll be the focus of this lesson 7.1. In inferential statistics, it helps with making inferences or predictions from the sample to the population the sample was taken from. And that's really going to be the really important aspect of statistics. Is you want to infer, you want to predict, determine if there is a correlation or a strength of association between an independent and dependent variable. And we'll be talking about that in the next lesson. So again, since the purpose of research is to test a hypothesis, it'd be important for us to review what a hypothesis is. And again, we talked about this in a previous lesson, but let's just review it here so we're, again, all on the same page before we move forward. So just a refresher on the hypotheses. An alternative hypothesis, indicated as H with a subscript 1. In this hypothesis, there is a significant difference or a correlation between variables, or a significant effect of an independent variable on a dependent variable. So in other words, the researcher is predicting that their experiment or their intervention is going to have an effect on the outcome. Now, there are some types of alternative hypotheses. One is a non-experimental, which means the differences or correlations or effects between two variables, they do exist, but they're not due to any manipulation of the variables by the researchers. They just exist. They're just there. Whereas experimental hypothesis is that differences or correlations, the associations, effects exist are due to the manipulation of the independent variable by the researcher. So in other words, the intervention that the researcher has utilized does have an effect on the outcome, and that's an experimental hypothesis. Now, there's also directional and non-directional alternative hypothesis. And directional is that the prediction that a variable will be significantly higher or lower than another variable. In other words, the researcher has a good idea of it's going to be higher or lower, at least predicts it be. So for example, a directional hypothesis might be that the researcher figures or hypothesize that this particular diet will have a decrease on body weight over 12 weeks. Or another one would be this resistance training protocol will have a significant increase in overall muscle mass after 12 weeks of resistance training. So that's a directional. They have an idea, they hypothesize that it'll be up or down depending on the intervention. Where a non-directional is a prediction that two variables will be significantly different, but they don't know exactly what the direction might be. So in this particular case, they just know there's going to be a difference, but they just don't know at the start of the experiment what it will be. And usually this is a non-directional, might be something that might be a preliminary study to a directional research, where initially you might do, hey, let's do a study. We don't know what the effect's going to be, up or down. And then a follow-up study is, once we have that data, then we can maybe determine a directional hypothesis. Now, the next is the null hypothesis, represented by H subscript 0, sometimes known as the H naught. And what this hypothesis indicates that there is no true correlation or a difference between variables, or there's no true effect of an independent variable on dependent variable. So in other words, you figure there will not be any type of change, as an example, or an effect. Now, there are three different versions of the null hypothesis to be aware of, but they all mean the same thing. So it's important to be aware of this. The observed correlations, differences, or effect are the result of random sampling error. In other words, the sample is not representative of population. Now, there also, you can see where there is no true correlation, difference, or effect, meaning what would have been found in a census of the population instead of a sample are not different. Or the true correlation, difference, or effect is really zero. The point of this is that with a null hypothesis, what they're really getting at is there's no true effect, or you're predicting there's not going to be any effect of the intervention on the outcome, for example. So however you write it, or however you see it, that's the overarching thing, that there's not going to be any effect potentially of an intervention on the outcomes. There are three options for researchers when determining the outcome. The first is the research study correctly identifies the correlation, differences, or effects. In other words, the alternative hypothesis was shown to be, or was supported by, the research study. So you might have indicated that there might have been an increase or decrease, and your research protocol showed that to be the case. So that'd be where the alternative hypothesis was correct. The second is that the research study incorrectly identified correlations, differences, or effects due to a bias in the research procedures. For example, measurement errors. So you might find there might be a situation where there might be differences, but it might be because how the data was collected was not done with reliable or accurate or valid measures. So that'd be an indication where you have an incorrect hypothesis was determined. The final is that the research study incorrectly identified correlations, differences, or effects due to a random sampling error. So it indicates that the way that the study was conducted was not the best, and therefore the outcomes may have been incorrectly supported. And so those are things that when you're reading the methodology and the statistical section that you would be looking out for. Now there's ways to test the null hypothesis. And, and we use significant tests, and they determine the probability that the null hypothesis is true. So remember, the null hypothesis means that there is no difference between the effect of the outcome or the intervention on the outcome. And we set this significance level, also called the alpha level, represented by this symbol, is set a priori, or before the study begins, and it's usually set at 0.05. Now, a significance level of 0.05 means that researchers are willing to accept that there is less than a 5% probability, represented as p less than 0.05, that the null hypothesis is true, or done by just by simple random chance. So what you're trying to find out, another way of looking at it, is that you're 95% sure that the differences that you saw in the study are actually due to the intervention and not by chance. So that is what you're trying to determine. So with this setting the probability of 5%. So if it's greater than 5%, that would be indicated that there are some analysis that you would need to do further. So let's talk about what would happen with values below 0.05 and above 0.05. If the statistical analysis result in a p-value less than 0.05, for example, p equals 0.03, then the researchers would reject the null hypothesis, indicating that the outcome was due just by chance. However, if the statistical analysis results in a p-value greater or less than 0.05, let's say, for example, p equals 0.055, so greater than 0.05, then the researchers would fail to reject the null hypothesis. So what this is trying to indicate is that if it's less than 0.05, you would reject the null hypothesis that the differences between, or that you found in the outcomes, is due by chance. If there's something that really happened, that the intervention had an effect. Or if it's less than, or excuse me, more than 0.05, then you would fail to reject the null hypothesis, and that you would be unsure or not whether or not the differences, if you did see them, were due by chance or by the intervention. So in this particular case, you would say there would be a statistically significant difference. In this particular case, you would indicate that there would be no difference between the two because it's greater than 0.05. One thing people will try to do, they'll say things that are, there's a trend towards significance. If it might be 0.06, for example, you want to try to avoid that type of language because it's really not going to be supported by the statistics. Now, there are situations where you'll see where the significance level is set much lower, say at 0.01, or in other cases, the significance level is set higher at 0.1. That's usually pretty rare. You'll see sometimes where it's 0.01. Either way, you would want to have some rationale and justification as to why they set the significance level at the level that they did. So another way of looking at significance level is that in research, there is a risk of making either a type 1 error or a type 2 error. Now, a type 1 error occurs when researchers reject a true null hypothesis, when it appears that there are differences and through the statistics, but in reality, there really wasn't any differences. That would be considered a type 1 error. So again, the type 1 error indicates that the outcome might say that there is a difference between the two variables, when in reality, there really was not. Okay, that's a type 1 error. The other is a type 2 error, when researchers reject a true alternative hypothesis. When the statistics, the researcher indicates there was really no difference between the two variables or the outcomes, but in reality, there really was a difference, and that'd be a type 2 error. Now, to avoid the risk of a type 1 error, researchers will set their alpha level lower, for example, at 0.01. But the downside to this is it increases the risk of a type 2 error occurring. So this is going to be very important, that if you set the alpha lower level, you reduce the chances of a type 1 error, but you increase the risk of a type 2 error. So let's look at some examples. Let's say you have a clinical drug trial and the efficacy of the new drug treatment for a form of cancer cells is being uh, determined. And so, but we also know that the drug treatment caused some side effects in rodent models. But the researcher wants to determine what the effect might be on humans. So, but to avoid any false hope or ineffective treatment and any health risks that might be associated with that treatment, uh, needs to be considered. So what they'll do is they'll set the significance level at 0.01 or a 1 out of 100 chance that the differences exist when they really don't. So by doing so, they want to determine at such a low alpha level, they want to determine and make sure that is basically the treatment of the drug outweighs any side effects that might occur with this. And so they can be rest assured that by setting it at such a low level that they can be confident that if there are any differences between in the outcomes, that it truly does exist. Now, another example, let's say you're doing a behavior intervention and you're trying to determine in a pilot study, a smaller study, the efficacy of new PE program in grade schools. And you wanted to identify potential strategies that could be used for a larger random controlled trial, which is RCT. Well, you plan to revise and improve strategies are identified as having potential to change behavior. So let's say in the study, you might identify several characteristics or strategies that might be effective. But this is a smaller study, and you're going to do a follow-up larger study. So in this case, you want to set the level at which the alpha at 0.10 before you would reject the null hypothesis a little higher, because you don't want to miss out on any potential strategies that might be worth testing in a larger study. So this gives you a little bit more of leeway. And you know that too, that you're going to be following up with a more rigorous, larger study. So in this particular case, you want to err on a little bit more freedom of accepting some of those strategies, as opposed to in our first example, where you're looking at a drug treatment, you want to be for sure that the changes that you see are true, and to dismiss potentially any side effects that might occur. In other words, is it worth it? So these are two different examples of where you might want to set the alpha level very low or a little bit higher. It just depends on the use and the outcomes that the researcher is trying to delineate. Now, in order to determine what type of statistics you're going to use, you need to understand the type of data that's going to be collected. And so we're going to be talking about the scales of measurement, the type of data in this next section. So this is the table that goes over the 4 scales of measurement, or the 4 scales of different data. So you go from the lowest level to the highest, and here is the scale. And looking at the 4 different ones, we have nominal, ordinal, interval, and ratio. The first is nominal, and that simply is a naming. And here you're going to be looking at race, gender, marital status, or a yes or no. And how these in quantifiable research, these 4 would be used. Now, in nominal, in quantifiable, you would, let's say, for gender, you would assign, let's say, 1 for female and 0 for male. And that doesn't mean that female is 1 greater than male, but rather you would use those numbers in order to quantify your sample. The next type is the ordinal, or where you're ordering or you're ranking. So in kinesiology, you might use health status or pain rating, or let's say the rate of perceived exertion. As you know, that scale goes from 6 to 20, where 6 means the individual is exerting almost no effort, whereas 20, they're at maximal effort. And that gives you kind of a scale. However, someone may have a 15, another person may have 16, their rating during, let's say, an exercise test. But ordinal will not tell you if there's any significant difference between 15 and 16. That's why we have to use the next 2 levels of scale of measurements, interval and ratio. So an interval scale of measurement, you have an equal interval without an absolute 0. So this is commonly used in psychological measures. So let's say you have a scale from 1 to up to 100. And one individual might score a 50, another individual might score a 60. Well, their difference in the scale is 10. Well, let's take you take another two individuals and the difference might be 70 and 80. The difference there is, again, 10. But it's highly unlikely that if you were to give a test, let's say over research methods, that there would actually be an absolute zero or absolute zero, no knowledge of research methods. So this would be an example where you have equal intervals, but without an absolute zero. In ratio data, they're equal intervals like interval. However, there is an absolute zero, and these are some of the examples here. A good example would be in height. For example, with height, there would be a potential at absolute zero. So, for example, in the height, it could be measured in centimeters, meters, inches, or feet. It is not possible to have a negative height. In contrast, when comparing to interval data, for example, temperature can be minus 10 degrees Celsius, but height cannot be in negative as stated above. So there's an example between interval and ratio, where interval has an absolute, or without an absolute zero. Another example, we talked about psychological measures, or say temperature, that could be below zero. Whereas ratio, again, they're equal intervals as interval data, but there is an absolute zero. You cannot have negative numbers. In this case, height or weight or age. You can't be negative any of these. And it's this ratio data that is especially most common in quantifiable or quantitative research. So this is just an overview of the different types of the basics descriptive statistics. In our next section, we're going to talk about how to measure these and analyze this quantitative data. So make sure you look over this before you go to the next section, which is quantifying the data.